So linear perspective is a system developed by an architect in the Renaissance that helps us really get a very convincing view or illusion of depth. And it's all based on the cube, or in more general terms, rectangular objects or boxy objects. Remember, it's an architect who's developing this. So of course he's going to be interested in how to convey depth in terms of buildings. Here I have the most basic form. This is the sort of the holy grail of linear perspective, the cube. So cube is basically a square in perspective, in depth. First of all, one of the things that you do as an artist is you create a vantage point, or what's called a station point. And that has to do with where you're placing yourself in terms of the drawing. So here's my piece of paper, and I've got it in horizontal or landscape mode. I'm going to be talking about something called the eye level line. The eye level line is basically the same as the horizon line, but we call it the eye level line because it really has to do with our eyes. So before I actually draw an eye level line, I want to explain a little bit about the eye level line. So if you were at the beach, let's just pretend you're at the beach. Not a bad place to be, right? And you're looking out across the water. You're looking out at the ocean, and you're seeing where the ocean meets the sky. That is the horizon line, and it's also your eye level line. So how can it be both? One has to do with your eyes, and one has to do with something very, very far away from you. Well, you can do an experiment and see how these things are connected. Just again, pretend you're at the beach and you're standing right on the beach, just on the sand, looking out. Now imagine that you actually lie down on the sand or sit down very low on the sand, and you're still looking out at the edge of the ocean. The amount of the ocean that you see will go down, it'll compress, because your eye level has changed. Same would be true if you went up higher. Maybe you went up on a cliff overlooking the ocean, and then you looked out. Now you would see more of the ocean because your eye level is higher. So the eye level actually will move with your eyes. So why is that important? Well, because the eye level line defines the ground plane, or the earth, or in the case of the beach, the water. Above the eye level line is the sky or space, and below the eye level line is the ground plane, or, depending on what you're looking at. I'm going to draw an eye level line on the paper. Now, where I place it is totally up to me. It's a horizontal line, and that's important to remember. So I just drew a line on the paper. That line is placing me in a particular place. I'm seeing more of the ground plane and less of the sky, which means that my position or my station point is higher up. So I'm looking down a little bit. If I were to place, let's just turn this over. If the eye level line were lower, that would mean that my eye level was lower also. So I would be looking up a little bit more. So you're not necessarily always going to be placing an eye level line on your paper, but it's important to understand that where you are determines your drawing to quite an extent. Flip this back over. So your eye level line becomes a very important part of this whole process. It's fairly simple in itself, right? It's a line. It's a horizontal line. But it affects how you see things. So linear perspective has to do with how things disappear into the distance. Let's go back to our cube here. Okay, cute little cube. We're going to talk about one-point perspective first. In one-point perspective, you're going to have something called a vanishing point, and in this case, just one of them. So taking our cube as our starting place, I'm going to draw a square on my paper. And I'm making it parallel to the paper itself. So there it is. So there's my square. How do I turn this into a cube? Before we start doing that, let's just talk about what we've already got. We have height, and we have width. So we have two dimensions. Remember, there's three dimensions: height, width, and depth. So we have height, we have width. How do we create depth? Well, that's where what's called a converging line or receding line comes into play. So remember, we talked about the fact that objects get smaller as they go back in space. So what if we created a smaller square behind the one we have? So I'm going to kind of freehand this, but I'll check it with my ruler. I'm going to create a square back here, where my height and my width are going to be perpendicular or parallel to the picture plane. So the picture plane is paper itself. My height lines are parallel to the sides. My top and bottom are parallel to the top and bottom of the paper. So let me just see what I've got here. That's about 1.5 inches. Make sure I really get a square. A little too tall there. I'll just drop it down a little bit there. Okay. Ooh, extra bit off there. So now I have two squares. I have one larger one and one smaller one. And one thing that you want to remember too is that I'm putting this smaller square a little higher than the bigger square. Now what I'm doing is I'm drawing some receding lines. See how those lines recede? I'm drawing them to touch this corner, this corner, this corner, and this corner. So those lines are diagonals, diagonal lines. And you can see that they're coming together on a point. Imagine that these are disappearing into the distance. They're going back in space. I'm going to now draw a line from the bottom of the box to that same place. Notice how these lines intersect those corners, and they all vanish to this one vanishing point. So this vanishing point, this is called one-point perspective because there's one vanishing point. So what we've actually done here is something called foreshortening. We've talked about foreshortening before, but foreshortening is really where you're shortening the amount that you see of an object because you want to convey that depth. Again, if I hold the little cube up to the camera, you can kind of see this. Just got to get it just right here. So notice holding it kind of low down. I'm going to hold it flat. See how you can see a lot of the front face, but only a little bit of the top. If you were to measure this length here, it would be quite a bit more than this. But you know that, in fact, they have the same, they are the same in terms of their actual length. but you have to shorten this length in order for it to look like it's going back in space. So 1-point perspective is the simplest form of linear perspective. It's only got one vanishing point, and that vanishing point needs to be either behind the box here, the cube, or it needs to be just maybe slightly to the side, but it can't be all the way over here, right? Because that would be 2-point perspective, which we're going to look at also. So 1-point perspective is a really great place to start learning how to use perspective. Now, another thing we want to think about is what are the angles that are being created by these diagonal lines? So I'm going to just use a darker pencil, and I'm going to go over these angles a bit. See that angle there? And this angle here? These are called acute angles. They're less than 90 degrees. The 90-degree angle would be this angle here, these angles here. So as the plane recedes into the distance, this angle is going to become more acute. I'm going to draw another box over here, a little bit closer to my eye level line. I'll use a different vanishing point for it so you don't get confused by this. So back to my cube, right? This time I'm going to put it very close to the eye level line. Here's my original cube, or square. I'll make it into a cube, or the illusion of a cube. So notice again, this has height. Height lines are vertical. Width lines are horizontal. It comes to a 90-degree angle at every corner. It's exactly the same as this one, but it's closer to the eye level line. So now I've got my vanishing point there. I'm going to just use my ruler to connect the corners to the vanishing point. So there's my lines going back in space. I have to make some back lines to really be able to see the cube. So I'm just guesstimating. I'm used to doing this, so I feel like I'm fairly good at figuring out where to put that back line. It takes a little practice. Just going to put it right about there. And then I'm creating, remember, a smaller cube in the back, or a smaller square. So I want to make sure that these lines stay horizontal and vertical. The only lines that are receding in this case are the depth lines. Now I'm going to use my ruler here because it's very, very tight. So now this becomes the top of my box. Here it's wider. Here it's narrower. I'm going to come back with my softer pencil and just go over that plane there so you can really see it. Look at how narrow that is. You probably wouldn't think that it could ever get that narrow because you know that it has the depth, right? You know that it has this amount of depth, and if I turn it, you'll see that it, oops, it's really hard to keep it level. You'll see how it flattens. So as the cube gets closer to the eye level line, the top plane especially is going to become narrower. This plane will also be narrower than this plane because it's closer to the eye level line. If I put my cube right on the eye level line, basically it's so flat that we don't see it at all. I'll put a vanishing point here, draw. I know to make this a little narrower than I made the other one. This plane should be narrower because it's higher up. Maybe that's a little too low. I've learned to trust my eye, but correction, always a good thing. Now I want to make sure that's really horizontal. It's important in perspective to be pretty exact. And then my height lines are vertical. So now my box, just going to go over it freehand here. That's the top of my box right there. You can't see anything except the flat line because it's sitting right on the eye level line. Let's do one more above the eye level line. Again, I want to make sure that is parallel. I don't want to tilt it like this. So above the eye level line, the same principle works. However, everything's going to go down towards the eye level line. The vanishing point in 1 point perspective is always on the eye level line. It's same for 2 point, but we'll get there. Let's not go to 2 point yet. So I'll put a vanishing point right here and draw the lines to it from the corners. What I'm doing here is I'm creating the planes of depth. I have height and width, and now I'm creating depth. So the depth lines in this case are the lines that are receding in space. Remember, I can only really draw 2 dimensions on a flat surface like this, so this is the illusion, right? This is the magic part. This is where perspective is like a really important power tool for you. I'll draw the bottom horizontal or width line here. And wherever I draw that, oops, maybe I'll make it a little bit higher. Again, I'm used to just using my eye to determine where to place that back line. Wherever it meets, that's where that horizontal is going to start, like so. Make sure that's parallel. A lot of times people will do this. No, the height lines in 1 point perspective are vertical, so you want to make sure that that line is vertical. And that's why I like the see-through ruler, because I can line it up really easily. Now sometimes you'll have this problem. See what happened here? That got a little bit off. Even just a little bit off can cause a problem. So I'm going to just erase that line out there and redraw it because it wasn't quite perfectly vertical. I'll just line it up with the eye level line and make sure that when I make my top line across like that, that it meets. So that's one reason why you really need to be fairly precise. Use a ruler. And let's just use a harder pencil or a softer pencil to define this box a little bit more. Now you can see the bottom plane of the box, not the top. So over above the eye level line, it just, you see the bottom instead of the top, but all the same rules apply. If I drop that down, I would see less of the bottom. So the position of in regards to the eye level line is very important in terms of what you actually see.